And so, good afternoon, friends. Today we have a very distinguished scientist from DRDO, Defense Research and Development Organization. This is the organization which is mandated to give the self-reliance to critical defense technologies, right from strategic systems to missiles, aircraft, radars, sonars, torpedoes, cyber security, information security, and also life support technologies. So he belongs to that organization as a very distinguished scientist. The distinguished scientist is the highest position. And he was also, he rose to the highest level of cadre to become a DG, Director General for Microelectronics and Devices, which is all the major systems of systems, subsystems, components, devices, everything ultimately get into micro devices, materials. So he has been dealing with microelectronics as well. Miniaturization is the focus. Now, how do you make it very compact? Then he was also dealing with all the labs dealing with computer science, like Center for Artificial Intelligence and Robotics, CARE, which is a major lab for artificial intelligence, information security. So he spent a long time there. Then he became director of a lab which deals with very sensitive key making systems, SAG and JCB. So SAG, he looked after that lab, which gives the scientific part to JCB, which makes the very important at the national level. So he was part of that SAG. He was the director of SAG. He became the director general for the microelectronics devices, computer science, artificial intelligence, cyber security. So all these domains were looked after by Dr. Athithan. So such a great person who has contributed immensely in the field and who is now here to share his ideas, thoughts, and also his own knowledge and wisdom in the field of cybersecurity, artificial intelligence, machine learning, deep learning. So all those related areas, particularly with the focus on cybersecurity, because this is the buzzword everywhere, because with all the attack, hacking, and information data getting stolen. So with all this, cybersecurity not only is significant, important for defense forces, but it is also very important for civilian sector. Whole economy is on cyberspace now. So if one has to destabilize, you can switch off. Similarly, the whole operations, military operations, Army, Navy, Air Force, they're all net-centric operations. So net-centric operations also demand a very high level of cyber security. Please settle down. Yeah, no, we'll add that. Some of you can come here. Please join here. So such a very important person is here, and he has given cybersecurity to at the national level, both the hardware, software, the testing system, certification system. So how do you say that this gives what level of protection, cybersecurity? So all this, he has been involved not only at the defense level, but also at the national level. Today morning, he gave a wonderful talk to a program being organized by Dr. Nitin Batraji, the CEO of our Amity Institute of Training and Development. And the whole program was arranged by Dr. Gopal Bhushan. So let's give a big clap to Dr. Gopal Bhushan, who was instrumental in arranging everything related to this. So my dear students, many of them are from, how many of you from the Amity Institute of Defense Technology? Just raise your hands. Very nice. How many of you from the IT, information technology? Great. And the rest are from assets, different aspect of Amity School of Engineering and Technology. So I wanted to make it very interactive. So this is not going to be a monologue. Students, we are going to ask you questions and you are going to ask questions to him. So please get actively involved because you people are the future. So I want you to assimilate each and every one of the words which he will be telling, so that then that will be the hypersonic propulsion which will give in your career, in your understanding of the cyber security, artificial intelligence. And we have with us Dr. M.K. Datta, who is an expert in the field of artificial intelligence. I'm so happy that you are here. And as Dr. Tania, who is looking after our cyber security, and she is the chief here, cyber security, Tania. And we have Dr. Sanal from aerospace, who was in NASA, he came back only a couple of days ago. And we have Dr. V.K. Jain, a stalwart from DRDO, whom you might have known, a very distinguished solid state physicist who has contributed immensely in defense, now in Amity for the last 12 years. He has been with Amity, a great innovator. We have Dr. Neeraj Sharma, who was the secretary of the TDB, Technology Development Board. And then Dr. A.K. Singh, whom you appear there as DG. So we are fortunate to have Dr. A.K. Singh. Yeah, very nice, very nice. And then Dr. Basant Singh Shikarwar is again outstanding researcher in Amity School of Engineering and Technology and head of the mechanical engineering. And he is also chief of the consortium, IIT consortium, where we have signed MOUs with I think about 6 or 7 of these IITs. And he is looking after as the chief of this consortium to bring collaboration with IIT. Then we have Dr. Rao, Neha, and I welcome each and every one of you, the very distinguished faculties who have joined us. Group Captain Kapil Shukla, he is there as he is the director of outcome. So we will be looking at how do we carry forward this outcome in terms of the discussions which we'll have for the various projects, program for collaboration with you as well as with CARE and DRDO. So with this, I once again welcome each and every one of you, and let's give a big clap to Goodwill who arranged everything, the whole arrangements for this event. And now a big clap for our students. You are the most important one. Let's big clap. Come on, louder. Yes. So with this, Dr. Athithan, founder president, Dr. Ashok K. Chauhan has attached a lot of importance to your visit. As I was following the conversation with you, and also founder president himself has kindly consented to be part of this program, and he will be listening, and maybe at the end, if there is a possibility.
Silvamurthy, after that, can I speak a few words? Can I speak a few words now?
Yes, sir, please, sir.
That's something I heard your full lecture. I think I compliment you, appreciate you, and Gopal Bhushan ji to invite Athithan ji. I had a detailed talk with him. ये आप लोग ऐसे लोग बुलाते हो which can change the world through amity. So I had so detailed talk, and I'm so impressed on this topic of neural area and artificial intelligence, machine learning. And I think this is one of the most important lecture for my person sitting in front of you. You name few persons. I told to Athithan ji that in all these areas, it is my obsession, जुनून and पागलपन. क्योंकि इसी से दुनिया बदलेंगे हम, और जो मेरे साइंटिस्ट बैठे हुए हैं, I told Athithan ji also there is no other institution in the country where such brilliant, self-motivated missionaries are there as my scientists sitting over here. So I think to all my scientists, this is a God-given opportunity that you are listening today to Athithan ji. He is a real expert in these areas, all these areas. And I think we will now, my job from today onward is to request Dr. Silvamurthy ji that we establish such areas. Hridesh Prakash is there, Kamal Rawal is there, MS Prasad is there, and Datta is there, Neeraj Sharma is there. They are all people, those who can really navigate this area better than any other place in the country. Sorry to say like that. And Athithan ji will be the mover and shaker for us. I have requested him to please guide us and advise us. And I told him also that also I'm making my university in Bangalore functional for this year or next year. because a lot of scientists are in Hyderabad and in Bangalore. So this, Athithanji, I'm doing this all on the order of Dr. Silvamurthy. He gives order and I have to implement it. I have to follow him. So I will not take much time. I'm proud on my scientist sitting over here. I think after this lecture, please make a note. I will then meet you all online, those who are attending it, to get your guidance further, how to go ahead. And Dr. Ramurthy and Gopal Bhushanji, my next opportunity, those who are here, and
Yes.
those who could not attend, we will send them URL. They
Right.
should also attend. I want to make a strong consortium of people in AI and all. Can I speak to Dr. 2 minutes? Dr. Datta, can Dr. Datta come on the mic? Dr. Datta.
Please come. He's coming, sir.
Dr. Datta.
Hi, sir. Good afternoon, sir.
First, welcome. You left the government or university government job where you could have worked till 65 years. So now our chancellor has great mission with help from you and Kamal Rawal and Hridesh Prakash and others to do in all these areas, cyber security, AI. So in today's lecture, I think you people will learn a lot. My idea is that we make a revolutionary center. We have already started with Hridesh Prakash. So please see from that angle that after that, I will be behind you, all my scientists, to make a center, what you call foundation or whatever you call, that in these areas, we are the #1 in the country and among the #1 on our top number in the world. Now you tell me what you do, how can you help in my ideas?
Anyway, sir, thank you for calling me over the dash. Artificial intelligence is something where the entire world is looking at, and a major amount of revenue is also being pumped in. Around 65% of revenue of the Fortune 500 company, they are pumping in not only in IT sector but also all other sectors like manufacturing sector, your automobile sector, everywhere. So the future is AI. And because I'm back here with that mission, we will definitely ensure maybe very soon that every student of Amit University, irrespective of his branch like management or engineering or science or pharmacy, they are to study at least one course on AI and relatively apply AI in their routine work, in their innovation, in their research. And of course, the engineering students from the engineering and the science background who have basic understanding of the algorithms, they're definitely going to do great work in actual AI architecture, developing architectures and optimizers that will definitely change the world. And the country at this moment need innovative solutions based on artificial intelligence, which I'd like to talk with. I'll have a discussion with the dignitaries. And as a country like India needing those customized solutions, we're definitely up there, sir, working on that with your all good wishes and blessings. We'll definitely make it one of the most predominantly the focused area of university and try to be the #1 in the country very soon.
Thank you. Dr. Athithanji, I heard your full lecture at ITech arranged by Dr. Nitin Batraji. Hello, Dr. Athithanji, I heard your Athithanji full lecture which you delivered in ITech, where people from 21 countries were sitting over there, and very impressive lecture, and they really liked very much. So I'm grateful that there also you could speak. So I will now leave upon my people. I request to my scientists, make an impression on Dr. Athithanji that we deserve his help, his guidance and directions. So when this impression you give, then I am the winner. Give him the impression that, sir, help us, guide us, advise us. That's all. Thank you, Dr. Ramurthy. Thank you.
Thank you, sir. Thank you for your kind words about the morning lecture. Thank you.
Thank you. Very good.
This is the passion, junoon of our founder president. Let's give a big clap to our founder president who takes so much interest. In spite of all the busy schedules, he finds time to be with us. And in fact, he was tracking whether his flight has landed on time. I saw his correspondence, sir. And so that shows the love and affection founder president has for Dr. Athithan and also for science, technology, and innovation. That is closest to his heart. So we all should deserve that we are in the right position to deserve that position. Now with this, let us now request Dr. Athithan, make it very informative, interactive, because I wanted to have a smaller group, not to have a big auditorium where just a lecture is given. I want this lecture that you should ask him, probe him, question, including my students, brilliant students from MTech Defense Technology, MTech Information Technology, and MTech Computer Science, all these people who are here that try to, whatever he says, also analyze, synthesize, interact with him. And we'll have 1 hour for interaction. We have kept minimum presentation, half an hour to 35, 40 minutes, but 1 hour for discussion. That is the purpose with which we should be able to look at what is the trajectory in which Amity should launch program with the competence available, expertise available. What should we do? So that should be the outcome, which Group Kapil Shukla and Astif, Abstia, all this will follow up subsequently. With this, I request the great distinguished scientist, Dr. G. Athithan, the former DG, and the presently a very important prestigious Nag Chaudhary Chair of DRDO at Center for Artificial Intelligence and Robotics. Let's give a big clap to Athithan once again. Thank you.
That's why they have supported our project of Shalini. Here, people came to us.
Yes, sir.
Am I right? The care
Yes.
people from Bangalore.
Exactly. And also to Professor M.S. Prasad
Correct.
for the project, TDF project, which has been sanctioned, sir.
Correct. Okay, thank you.
Thank you, sir.
Good afternoon to everyone. Are you able to hear me? The last row is busy looking at their mobiles. Dr. Ashok Chauhan-ji, firstly, I thank you for the opportunity given to me. I'll use this. Dr. Ashok Chauhan-ji, firstly, I would like to thank you for the opportunity given to me to speak to your colleagues here, your students here. I really appreciate the initiative you have taken. But your expectations are quite honestly unnerving. Let me see if I can live up to those very high expectations you have set.
Right.
Then I would like to thank both fellow panelists on the podium, Dr. Sellamurthy and Dr. Gopal Bhushan, for facilitating this visit of mine here for interfacing with me. And there were a few others like Amit Chauhan and others who also played their part. And I'm glad to see Dr. A.K. Singh, my former colleague, and Dr. Neeraj Sharma, Secretary TDB, and senior colleague V.K. Jain from SSPL DRDO, and Dr. Datta, and many other faculty members of Amity University. And also glad to see a lot of young students from defense technology and also information technology branches. Can the slide be lowered a little bit, or this is the position? Okay, but there is some something blocking the top line that can be cancelled. Yeah, bring it now. Right. No, I'll do that. Yeah. Dr. Sellamurthy, when you introduced me, you said I'm going to talk about AI and also cybersecurity. I would like to clarify a little bit. The cybersecurity job is already done and dusted. That was done in the morning, which Dr. Ashok Chauhan also mentioned. That was done in the iTech seminar or training course, I think, to the international participants. It was good. I enjoyed it. But this particular talk is going to be only on AI, focused on AI. But I didn't know, in fact, what were the actual expectations. Now, things are a bit more clear. This talk will be at a certain tutorial level. Okay, but it will be based on my understanding, my insights into this domain. Though, of course, I was mostly a cybersecurity expert. Cybersecurity requires understanding of computer science. And AI comes under computer science. And as Director General of Microelectronic Devices and also Computational Systems and Cyber Systems, I was involved in supervising many artificial intelligence related projects. Can't share details of them, but all that in fact gave me the background and also the necessary experience to talk to you at a certain accessible level. That is what is actually important. Otherwise, AI means different things to different people because it is as complex as the human brain itself. The ultimate objective of AI is to mimic the human brain at large scale, at scale. And that is actually scary and also a great opportunity. So we will find out, during the course of the discussion today. So let's get on with the talk straight away. First, a perspective on artificial intelligence and machine learning. As you can see on the right side, there is a Venn diagram. AI is a superset of what is generally called machine learning. Machine learning actually extracts knowledge from data. Data could be images or sentences, whatever. Audio also, video. And neural networks, which are in fact powering the AI paradigm now in terms of deep learning. Deep learning is nothing but highly multi-layered neural networks with maybe new types of activation functions at different layers and new ways of, in fact, architecting the layers also. So basically, neural networks are the theme of the talk today. And they are the heart of deep learning. But they are a subset of machine learning. So let me just share with you my, understanding of what is AI. AI is basically to simulate human intelligence. As simple as that. Sometimes you hear very complex definitions. No, it is just to simulate human intelligence. That's it, right? And we have not done it yet. We are, making tentative steps. But in a practical way, it also could mean that applying knowledge to achieve set goals and extracting knowledge from data and doing better every time that knowledge is applied. So this is some kind of a working definition, if you ask me. But the knowledge actually can be sometimes handcrafted. It used to be handcrafted in the earlier days, in the 1980s. AI is a very old field. I think it was started, properly speaking, 1950s. Even 40s, neural networks are invented in 40s. AI properly was coined in 1956, Dartmouth conference and all that, some of you may know. So it's a very old field. But in the 70s and 80s, you might have heard about expert systems. They were very popular. And they were used for giving medical diagnosis, predicting, in fact, the final compound in case of, constituents of the chemical compound are given. Many things were done, attempted. But they were based on what is called handcrafted knowledge. So knowledge used to be in the form of rules, okay? So that is where this, the part of AI outside ML lies. So there is some part of this Venn diagram outside of the ML part of the Venn diagram. That is where handcrafted knowledge-based AI lies. And it is still a meaningful thing to do, because it depends on what is the job at hand you want to solve. If it is a limited industry environment, you can still go for handcrafted knowledge. Don't be shy. Don't think I have to somehow use neural networks. No. You can actually collect all the knowledge that is already available. You'll have to only make sure that knowledge is complete, consistent, sufficient for the purpose at hand. So that is still a meaningful thing to do. But machine learning, it extracts and uses knowledge from labeled data. Data has to be labeled properly, curated properly. Bad data should be removed as far as possible. So this is data-driven approach. But here, when we say extract knowledge, the knowledge can be explicit or implicit. Explicit means you can actually see rules or some kind of a graph, ontological, connections between nodes. Or it can be a speaker model. Okay, you can actually look at the model of each speaker for speaker identification. So that is what is explicit knowledge-based system. But you can also have implicit knowledge-based system where you cannot really put a finger exactly as to where that semantically clear knowledge is located. Unfortunately for us, neural networks belong to this category, though they are very powerful. Okay, so neural networks are basically implicit knowledge-based systems. And because they are architected based on fundamentals of brain to a limited extent. In fact, the brain is a very complex system even today. We are constantly improving our understanding of the human brain. We know that there are these neurons, which are the fundamental processing elements. There are connections between the neurons, which are called the synapses. That is where the learning happens. Modifications of the synapses represent learning. And then, of course, the knowledge is applied by way of reaching output, generating output for input. So based on this, we have created the basic neural network models, but a lot more happens in the brain. We can probably touch upon that during the discussion. Knowledge is extracted again from labeled data only, like in the case of explicit knowledge extraction, but represented implicitly. As I said, many models exist. The most dominant model is deep neural network. What is deep neural network? Simply many layers. And the number of layers today can be hundreds, if not thousands. Okay, so each layer actually can have 100 nodes. So we are talking about 1 million nodes and going upwards of billion nodes. Just to give you some rough idea in the context of this slide, the chat bot that we are talking about uses a language model called GPT-3. Chatbot is only an application running on top of GPT-3. GPT is generative pre-trained transformer 3, version 3, right? So it uses apparently 170 billion parameters. 170 billion parameters actually means that many connections, so to speak. Okay. You see the astronomical number that is involved. I understand Google's GPT called the Lambda, L-A-M-D-A. Google also has a large language model. It is bigger than, in fact, GPT. GPT and ChatGPT come from one company called OpenAI, sponsored by Microsoft. But Google has its own independent language model, and also its new chat bot that is called Bard or something like that. You must have heard about it. It is trying to develop it. It is actually playing a catch-up game, etc. But that's another story. So in terms of size, these current neural networks are huge. Are they catching up with the human brain? Okay, it's good to pause here, and look at the numbers involved in the actual human brain. The average brain has about 100 billion neurons. Okay, it is less than 170 billion. But when it comes to number of parameters, you should not look at the neurons. You should look at the connections between neurons. So on an average, each neuron has got about 1,000 to 5,000 connections. So you have to multiply that 100 billion by 5,000. So we are still far away from the actual human brain in terms of even the raw capacity. Okay, so let's keep this in mind. Let's go to the next slide. Now, I'll quickly highlight some of the applications of AI. I'll not spend too much time here, just to set the background. In any discussion, there is a foreground and there must be a background. And the background should constantly inform you whether the foreground is going in the proper direction or not. So first thing that we do in AI is searching and optimization. Identifying objects of interest in a given state space. So you know very well the breadth first, depth first, and best first methods. Branch and bound for integer optimization, right? And we all know the Google's PageRank algorithm, which is pictorially explained on the right side. Game playing, that has been traditionally considered heart of AI. Well, only humans can play games. It requires thinking. Chess is a game. But now it is known that chess is a computation. But computers, in fact, play chess very well as a result. So this is the approach for gameplay. So I make one move, the opponent makes any one of his possible moves, and then for each move, I in fact a counter move. This way a tree gets expanded. And each level, you can assess the capability, capacity of that particular node and do a best selection of the node at the deepest levels possible. And how many levels you can go depends on the compute capability that you have. Okay, so game playing is an application. Game playing is especially useful for defense forces. War gaming actually is an application of game playing, but at a much bigger complexity than what can be in fact taught in universities. Now, the next two important applications are reasoning and problem solving. The expert systems I mentioned. So, you create an expert system based on known knowledge, handcrafted knowledge. Then when symptoms are given, it has to actually inform you what is the disease or what is the troubleshooting, or for any other kind of mapping, you can use reasoning and problem solving. But this requires explicit knowledge representations in terms of decision trees, ontologies, frame scripts. These are all very familiar to computer scientists or those who are learning computer science. But planning is a very important requirement, especially in autonomous systems. That is another rage. So you have deep learning on the one hand, but another area which is very important for all of us, for military also, is autonomous systems. Systems actually should not require a driver. They should in fact know the environment, perceive the environment, navigate the environment at very high speeds, and they should know the goal where they should reach and avoid obstacles, avoid collisions, sudden developments happening on the road, like a cattle crossing the road, all that it has to perceive at lightning speed and still reach the end goal. So here again, planning is required, AI is required. You are familiar with Dijkstra's algorithm, A-star algorithm, but we need more sophisticated algorithms. Here, perception at scale, perception at real time is very much required. Deep learning networks have actually risen to the occasion challenge. I'll come to that. Then you have computer vision itself. In fact, these are the two areas where deep learning has made great impact. A computer vision success story is an earlier success story. It started sometime in the middle of previous decade, or even I would say the 2000s. Then 2010s, in fact, it made great advances. That is when the convolutional neural network, CNN, was introduced. So what is convolutional neural network? How it is different from the earlier multi-layer neural networks? Earlier also we had multi-layer neural networks. In the case of convolutional neural network, new layers were introduced, particularly one layer called simply convolutional layer, which is supposed to pick up features from the images, still images or videos, okay, using some kind of a stencil, some kind of a filter. The next layer was expected to reduce the dimensionality, because in an image or a video, you have lots of pixels, then that means a lot of dimensionality. You have to reduce the dimensionality to smaller levels for more intelligent, noise-free pattern recognition. So that is called a max pool. In a pool, you just pick up the maximum value, maximum element, etc. Then comes the fully connected layer, which is quite well known in the multi-layer perceptron model. So that is how computer vision, in fact, became a big success story. The results, in fact, were breathtaking, particularly when applied to handwritten character recognition. The accuracy achieved was much more than what an average human being was able to do. That was quite remarkable. I mean, close to 99.60, whereas human accuracy was 1 or 2 notches less. That is when people sat up and take note. Oh, now computer vision can be done by neural networks better than human beings. And that could be easily generalized. But I was optimistic about this computer vision. I had no doubt about the possibility of this. But I was really surprised to know the success of deep learning in speech and language processing. This is a very new development. It's possibly 6 or 7 years old or even less. What has happened is now deep neural networks are outperforming all the known methods in machine translation, summarization, speech to text conversion, text to speech conversion, and even producing conversations, answering question and answers. Okay, so we will spend some time discussing about the successes, challenges, and also, concerns that we should actually keep in mind. Okay? This is only broadly to tell you what is the current status of applications of AI. I know you are eagerly waiting for the real stuff. So machine learning, this I had already introduced you, but I'll give you some information about what are the existing techniques for converting this data into explicit knowledge. Some of you may know, but many of you may not know. There is something called iterative dichotomizer. It's called ID3. It's a forerunner in the space. It was proposed by one Quinlan. So on the right, you see a figure, this figure. So you see a simple data table, database tables are familiar. So you have attributes, field values. So you have 4 independent variables and 1 dependent variable. So this table is known. This algorithm ID3, and also there are other algorithms called C4.5 and CART. They convert this into a decision tree like this. Decision tree is, when you have a new record, see, this is existing record. Some new record comes, you can find what is the dependent variable value for it by going through this tree. You start with the root node, take a left branch, right branch, or appropriate branch. You come to one of the leaf nodes. So that is the class value for that particular input data. It's very simple. Again, you should try to apply these things. Not everything is speech recognition. Not everything is chatbot. In industry, you require, in fact, applications of these techniques. The scope is fairly well defined. You don't have to deal with the complexities of the real world. There are many environments where these kinds of simple techniques, handcrafted knowledge is one thing, but generating knowledge in an explicit way is another thing. Let me also tell you why it is important to actually go for explicit knowledge. I'm just jumping the gun, but it is good to keep your motivation alive. Only when the knowledge is explicit, you can work out an explanation. And explanations are required. One problem with neural networks is they cannot give you an explanation. They can do an excellent job, but they cannot give you an explanation. If explainability is not there, what is the downside? We will discuss that. Keep that point in mind. So the next important machine learning technology is graphical models. Again, probabilistic graphical models. These are again a range. In this category come this Gaussian mixture models for speaker recognition, and then hidden Markov models for speech recognition. I told you before deep learning networks, there are other models for speech processing. HMMs were very popular for speech processing to convert speech to text. We see that all the time in YouTube videos. Once you select generate text, subtitling, then automatically text is produced. The text is reasonably good. But let me tell you, those are not done by now HMMs. They are done by deep learning networks. And they do a pretty good job. Even when you make mistake, your text comes out better. That much I have seen myself. Sometimes we have some hesitation. We make some, throat clearing sounds. And in spite of all that, that produces beautiful text. So wonderful. Welcome to the world of deep learning. So these are explicit knowledge-based things. There is one more concept called reinforcement learning. This is making waves. I think you should know something about it. Reinforcement learning is not your typical backpropagation learning, where input is given, there is output, there is an error at the output, the error has to be propagated backwards. This is done. This is the bread and butter of all deep learning architecture. But in reinforcement learning, what is done is, in a complex state space, depending on where you are, you have to make an incremental step in the right direction towards the goal state. In a simple space, this approach will work. But in a complex space, you will get trapped in what is called a local minimum. You will not know how to jump off that local minimum. People tried the simulated annealing, but they were all, in fact, half-hearted efforts. So this is a general problem, getting trapped in local minima, not reaching the correct goal or the global minimum. Okay. So this problem got solved to some extent by large computing capabilities of GPUs and all that. Now, instead of making small steps, you can make multiple steps before assessing the quality of the output. You get the point? But in any complex space, if you start making more than one step at a time, then the compute capability required goes up enormously, because the number of steps is increased. The number of options to explore actually becomes combinatorially very large. But with very powerful computers, you can actually explore multiple steps before assessing the quality of actually the choice. So interestingly, a lot of success has been achieved by this multi-step exploration of complex game spaces. And this reinforcement learning based systems, in fact, are defeating world champions in Go in many games. I think some of you would have read. And one gold champion, global champion or world champion of Go, one Korean, I think, he was asked about his experience after he got defeated. And he said, I don't know, it was using some new method for moving, which I, as a human being, I had not heard of. And I can, vouchify for others also that the mission is in fact trying totally new things. This is, people say that, machine learning things can get as new insights. So this is there on the record. So reinforcement learning is making a lot of waves. It will be very useful for defense forces. And finally, in this area, data centers and their roles, that is important. In fact, since Dr. Ashok Chauhanji mentioned about, growing capability in this area, the first thing that you have to start is plan some huge data center. See how you can collect data from various corners of the country, and how you can curate them, how you can in fact label them, how you can archive them, how you can create interfaces for accessing that data. This way you can in fact amplify, you can actually create opportunities for many different teams in your own university chain and for others also to generate new technologies or new solutions based on neural network technology. So this is a very important role that we have to look at. I'm just skipping, in fact, explanation of the diagrams on the right side, but those diagrams basically explain whatever I am telling about the concepts. And now we come to the heart of the talk, neural networks, because they are so successful, we for the moment ignore about the explainability issue or unexplainability aspect of it. As I said, they started with understanding biological neurons. Okay, this little bit history is good to know. Okay, so bear with me. It is also good to celebrate people who discovered these things. You should know the names of some of these people. Recognition of neuron as the key functional unit or cell of the human brain. It happened as early as 1890s, more than 100 years old. This it is attributed to Golgi and Cayol. I think Cayol, at least, is a Spanish scientist. I don't know about Golgi. But there are names like Golgi apparatus. A life science DG actually will know, he's smiling. And then interplay between spinal cord and limb muscles mediated by neurons. That was discovered by Charles Sherrington in the 1900s. Again, way back. And he is supposed to have said brain is like an enchanted loom. That was the analogy he used. The same thing was, mentioned by one famous poet of German origin, Goethe. He also says brain is like a enchanted loom. Of course, he has a nice 6-line poem. Time permits, I'll try to recall. But the most important breakthrough, in my opinion, happened in the 1950s. Ionic processes at the synaptic connections between output axons and input to dendrite pathways was discovered by this John Eccles. He's a New Zealand or Australian scientist working in UK at the time. Based on this, artificial neural networks were created. Based on all this knowledge, in the 1940s, there was an abstraction of a neuron as a unit with binary state. And then there was perceptron. Many of you, who have studied the history of neural networks know what is a perceptron. It's a single neuron with multiple dendrites giving an output on the output axon. And it was able to do some simple classifications. Okay, so whether the particular face is that of some X person or not. Binary decision process, it was able to do. But somebody came along and criticized perceptron because he said perceptron cannot learn some other slightly more complicated functions like XOR function. What is XOR function in Boolean logic? I think many of you might know. I'll not spend time on it. So once somebody made that criticism, that field actually collapsed. Then it was in dormant state. Then came in the 1980s. This multi-layer perceptron. You add additional layers to the perceptron, then the XOR function can be learned. After all, neural networks are modeled after the human brain, even though the modeling had maybe slightly inaccurate or incomplete. But you cannot discount anything based on the human brain. Any model that was, so by making a simple innovation of adding one more layer, that criticism against the neural network that it cannot learn XOR function was easily pushed away. So that innovation was created by Rummel, Hart, and McClelland in the 1980s. But interestingly, there is a bit of history. There's a person whose face you see on the right bottom. His name is Paul Verbos. Interesting. He's a control theory scientist. He had discovered this backpropagation algorithm much before Rummel, Hart, and McClelland. This came later. This discovery came later, but it is okay. The credit is actually shared by both. There are some facts about MLPs. I'll focus only on the second point, which is successful training is based on trial and error. Depends on the quality and quantity of the training data, number of layers, size of each layer, etc. So this remains till date a criticism which is valid. Because here learning actually means converging to the global optimum, and that is generally not possible. That is the main problem. So capabilities of MLPs, this is a very important slide. They can, in principle, learn any function or any transformation of input to output given adequate training data, any function. So if in fact intelligence is, taking input and creating corresponding functional output, that is, if the input is X, function is F, you should be able to get F of X. If a neural network can do this, regardless of F, that is a great achievement. And that is what has been proven very clearly. During discussion, I'll explain to you. I don't want to, in fact, digress too much from the presentation now. But if there is one single additional layer, then the size of that additional layer must be unbounded, meaning it should be very large. Just to explain the deep meaning of this particular sentence, supposing you want your neural network to learn multiplication. Possible or not? It is possible. You want to give 2 4-bit operands and you want to produce what 8-bit result, okay, maximum. It is possible. You can have a lookup table, in fact. Why in the neural network? You can have a lookup table. But neural network also can do the job. But if you have a limited number of neurons in the middle layer, it can give only an approximate result for new inputs. So the beauty of neural network is you don't have to exhaustively train it. You train it with a subset of the data, then for other data, it will produce an approximate result. But in the case of multiplication, unfortunately, you cannot settle for an approximate result. You want an exact result. So you want an exact result, you have to give exhaustively all inputs. So if you take 2 32-bit operands, how many rows will be there in the table? 2 to the power 64. And 2 to the power 64 tables, can you have? Even in the biggest computer, you don't have that kind of memory. So therefore, a neural network, a single layer neural network in practice cannot learn multiplication. Why? The simple fact is multiplication involves multi-step computation. Mostly neural networks can handle competently single-step computation, but multi-step computations are a big challenge. We will keep this point and we'll revisit this. But instead of having a single additional layer, if you are allowed to have multiple additional layers, the sizes can be moderate. You don't have to have very large single layer, but you can have moderate additional layers. The complexity is tamed at each layer. So multi-layer approach for learning multi-step functions is reasonably more practical. And this is an important point. So as a result, object recognition, speech and language processing has become possible. MLP with many additional layers of bounded size, as I highlighted earlier, is the deep neural network. The innovations behind the successes of deep neural networks are in the functions of the additional layer, which I highlighted in terms of feature selection using convolutional layer and then max pool layer for reducing the number of features, because you cannot deal with too many features or too large a feature dimensional space. Now we come to recurrent neural networks. What we saw earlier is okay for computer vision. where you can process still images or snaps of video frames. But what is now more exciting actually is processing language, processing sequences. For processing sequences, there is a different kind of network called a recurrent neural network. The earliest model was the Hopfield model. I will not spend too much time on it because of lack of time. But you just focus on the second part of the slide, which is called the basic recurrent neural networks. And there is a diagram on the right side. I don't know whether you are able to see it very clearly. Let me try to expand it because this diagram is important. Oh, this is a PDF, is it? Not the, okay. So then we will come back to this during discussion. How do I go to presentation mode? Yeah, okay. So here, though you are not able to see the symbols, you can see the network here. See, there is, this actually shows in some kind of a notational form, the entire sequence unrolled on the right side by this feedback loop. But what happens here is there is that input here, and there is also another input, some output comes. Then the context of this input goes to the next stage. Next stage, a new input is given. And the third stage, another new input is given. But the input from the previous stages is, abstracted in the form of context or background. And that actually decides on the output of successive stages. So you can see the power of this to deal with sequences. So if you have a sentence, let us say of 10 words, if you give 9 words, this kind of a network, after learning from multiple examples, can produce a 10th word and complete the sentence. So you have a sentence of 5 words, 4 words you give, it should predict the last word correctly. So that completes the sentence syntactically and grammatically. Is it possible? It has been proven to be possible, provided you have given sufficiently large number of data. It is able to generatively create that. Even if it has not seen that sentence, it is able to create the word correctly for the last position. And this can be generalized. We will come to that point maybe in a few subsequent slides. I hope you got the gist of what is meant by this recurrent neural networks. But basically, they are a finite number of stages. That depends on what is the longest sentence you want to handle. It is stuck. Yeah. Now, developments in the recent decade. So far, we saw a little bit history of neural networks, about what they can do for learning any general function, produce a necessary output, and then what they can do to process sequences. Now, recent developments is this rectified linear unit. See, there is a thing called activation function. We talk about neurons in the multiple layers. No, these neurons are supposed to do this kind of functional transformation. This is called a sigmoid function. This was the bread and butter of a lot of neural networks from the 1980s. But when this convolutional neural networks introduced, this new activation function was tried. This new function, as you can see, up to some point, the output is 0. Once the output crosses a certain value, the output is linear to the input, the excess of the input over a threshold. In fact, actual neurons behave like this. In actual neurons, the brain, it doesn't fire till actually the activity reaches a critical level. Once the critical level is reached, after that, the frequency of firing of the neuron, see, there is a thing called the frequency of firing. But in two-state neurons, that is ignored. When McCulloch-Pitts actually created the two-state neuron, he ignored the frequency of firing. But in practice, frequency of firing actually represents the strength of the stimulus. So when that is taken into account, the results that you can achieve actually becomes dramatically more significant. So that is one benefit of this ReLU. Then there is this this innovation actually was done by Jan LeCun, quite a well-known authority in the convolutional neural network space. Then the result of above innovations is what you see as real-time object recognition. There is a technology called YOLO, version 1, version 2, version 3, version 4, etc. One second. Hello. Yes. Yes. No, I'm waiting. Sorry. Yeah. Sorry about this interruption. They keep coming. So I was talking about autonomous systems. They have to perceive. You can switch it off, sir. They have to perceive and then decide based on the perception navigation. For this, real-time object recognition is required. The real-time object recognition was coming through this convolutional neural networks, and this YOLO systems are able to produce a picture like this, where you see bounding boxes. These boxes are basically scoping the object that is identified and recognized and identified. So this is a car. In fact, the top left, the label also generally is written. Some person is walking here, and there is a lamp post somewhere. All these thing happens in real time. So when this technology was ready about 7 or 8 years ago, people thought autonomous car driving is done. Now, within some 4 or 5 years, we will have all autonomous cars. But then there are other problems that came up. We will discuss that if possible. But this technology is already there. It can be further improved. This is going to be a very key technology for autonomous systems, and that is going to be very useful for defense systems. Defense technology people should note this. As I said, RNNs, the dominant models used to be long short-term memory, but now transformer is the leading technology. That's a reason that word transformer is there in GPT, generative pre-trained, transformer. Transformer is that particular block that is repeatedly used in the multi-layer recurrent neural networks. And they are called, in fact, in some domains, encoder, decoder. Encoder is something that encodes the input sentence. Decoder is that produces the target sentence. If you are, for example, talking about machine translation, encoder takes the source language input, converts that gradually into context, and then finally produces by decoding the target language equivalent sentence. Okay. Now, further developments in the recent decade, this I think we can ignore. Basically, it says data-rich internet is helping. Investment from multinationals is helping. This is quite well known. Google has got TensorFlow. Your Facebook has got PyTorch. Most of you are familiar with these things, these libraries. Practically everybody in the world is using, even in India. These things are helping students to learn. Lessons from the past AI seasons. I think the next 2 slides are very important. Whether we should follow this syntactic approach for natural language processing. Neural networks, what kind of approach they are following? On the face of it, they are following statistical approach, right? We will discuss it if some of you disagree. But traditionally, people thought we should understand the structure of a sentence, because the structure has got long distance connections. For example, if there is a subject and there is a declension for the subject, which is some 3 or 4 words away, that is a long distance relationship. How statistics will capture that? Because statistics can capture only what is coming next and so on. But interestingly, statistics has gone beyond that to only predicting what is coming next. In the process of learning what is coming next, it is actually learning also what comes likely to come after 4 words, after 10 words, etc., etc. Okay, we will just revisit this point in discussion. So a lot of time people thought syntax is the correct approach, but syntax has proven to be fragile. in the presence of errors. When there is an error, it is difficult to produce a syntactical tree. And probabilistic grammars, in fact, have not really grown up to deal with errors. Okay. So statistical approach based on phrases also, showed promise very briefly, but the neural approach is the most promising and likely to be the dominant theme for the next 10 years or 20 years. Knowledge representation using rules was attempted in the 80s. There is this famous person called Doug Leonard. He created the CYC. He thought alone by, in fact, using his students and others, he can, in fact, create this very huge global common sense knowledge base. Common sense knowledge is required for reasoning, right? Not perhaps for natural language processing or for computer vision, but for reasoning, it is certainly required. But it did not succeed. It did not come to a safe conclusion for various reasons, because one of the reasons is who will guarantee consistency? Meaning all these rules are consistent with each other. When you keep adding new rules, it's going to become a bigger and bigger task. And completeness also is always a question. What if there are contradictions that are entering into the knowledge base? That was a big challenge. For computer vision, statistical pattern recognition used to be the dominant theme, but now I explained to you convolutional neural networks have overtaken. The reason convolutional neural networks are selecting features on their own, whereas statistical pattern recognition, you have to tell the system what the features it should compute and then what the features it should use. So that is a kind of handcrafting approach which did not actually scale. It did not even pick the right features. So that is the issue. Now the general outlook is for deterministic and clean domains, syntax-based approaches queen. For example, to tell the digital computers what to do. You are not going to tell the digital computer using a neural language what it should do. It will continue to be based on Python language, which is actually a deterministic formal computer language. Okay. So deterministic clean domain syntax-based approach is fine. Syntactic or symbolic approach can support interpretation of results, but the output of NN or connections approach has to be accepted without any explanations. But I must share with you that research efforts to extract rules from trained neural networks have been not fruitful. People thought, okay, these neural networks are learning knowledge, extracting knowledge from data. Is it possible to see some kind of semantics in the connection weights? Some kind of rules can we extract? To the best of my knowledge, I know some attempts made in India, made in CARE, made in DRDO labs, but this approach has not succeeded. So we are still groping in the dark as to how to interpret semantically the weight values in the connection networks. So neural networks still cannot explain their decision making. So contemporary applications, here I can rush through. Advanced industrial automation, video analytics to detect what activity is going on. It will be very useful in many human activity improvement scenarios. To check whether an employee is performing his duties efficiently and correctly. All that is possible through this activity analysis. Speech and language processing I mentioned, autonomous and unmanned vehicles. Search and find mission, you can see a nice figure here. So flying drone can do pattern recognition or person identification and then send appropriate information for rescue teams. So directions for R&D, we have to think in terms of new architectures, deep learning architectures, for which we can perhaps go to the brain and look at the other half, which we have not yet understood. We have understood maybe some part of the brain, but large parts of the brain remain, in fact, ununderstood. So is it possible for us to look at that part of the brain and learn something? And you also have to go into sparse data domains, because neural networks are data hungry. If a domain has got not enough data, then you cannot hope to train a neural network. For example, you want to do machine translation. If there is a domain of language where a lot of source data is not available, you can't hope to translate from that source to some other important or interesting target language. So we have to deal with that. There is one important thing called bias. If AI has to be widely applied, it should be bias free. Or let us say, for the sake of argument, somebody's loan application is rejected based on some AI processing. That person has to be given some explanation. Otherwise, it won't be accepted legally, right? So explanation is required. Explanation is required in many other scenarios. In autonomy, there is one level called man in the loop level. That is, man is not intervening constantly, but he approves the decision of the AI system. He will approve only when he gets an acceptable explanation. So for this also explanation is required. Sometimes if explanations are given, we can recognize also errors being made by the system. Otherwise, we will not know whether the system is making an error or making a correct classification. As I said, incorporation of explainability should be an important domain of research. Thankfully, we have come to the end of the slide. So some of the references here can be followed up further. I would like you to read the second reference in the unreasonable effectiveness of deep learning in artificial intelligence. This particular phrase, reminds me of Eugene Wigner, famous physicist. He said about the unreasonable effectiveness of mathematics in natural sciences, which is actually easy thing to understand. But this particular paper was written based on an inspiration from that particular concept of Eugene Wigner. Then there is this nice book, openly available in the net, Neural Networks and Deep Learning. I talked about how deep learning networks can learn any function, given enough training data. He explains it in a very systematic pedagogical manner in this book. And then Internet Image Repository. So just follow up these references, you will get a lot more new threads to explore. This is the last slide, but well, we always keep talking about artificial intelligence, but there is a lot of natural stupidity that we don't know how computers will match because there is only one way to succeed, but there is many ways to fail. So it's very difficult to in fact simulate the many ways of failure. In a computer, of course, in real life, it happens all the time. So thank you very much for your patient listening. Take my seat. Sorry, stand there.
Friends, you have been listening to a very important, the fundamental basics, as well as the recent advancement in artificial neural network and artificial intelligence. And this is a very important part today because AI is coming in all domains, be it in food security, energy security, health, everywhere AI application is coming in a big way. We are also joined by Dr. Sugata Gangopadhyaya. Can you just see? He is professor and head of computer science from IIT Roorkee. And again, the Gopal has invited him for collaborations, see the possibility for interactions. So maybe he will share some thoughts at the end as well. I'll request Dr. Sujat. Thank you for joining us. Actually, he just finished his lecture in ITC. And this is a very important program that Nitin Batraji is organizing. This is like a technology diplomacy, science diplomacy. Here we are also giving our learning to our friendly countries through the Ministry of External Affairs. So Nitin Batraji should be also complimented for such initiatives he is bringing. And Professor Gangopadhyaya also gave a lecture just now, like Dr. Athithan gave in the morning. Now he just completed. We will also listen to him later at the end of the discussion. So now the presentation is open to discussion. Would you like to make any comments, Dr. Datta? You can give the.
Okay. First of all, thank you, sir, for your very nice and wonderful lecture. Maybe I may not have any more, comments. It was very nicely explained. I just want to tell the students, the defense technology students and the other students present over here, We are starting very soon a Center for Artificial Intelligence in Ahmed University. So any one of you who are actually keen in working on any problem relating to vision, I mean 2D, computer vision or time series 1D or informatics, you can approach me, or Shilpi is here, Vedatri is here. There are some people who are working with me. So I think that today's talk must be an eye opener where it will definitely motivate you. And the future is definitely AI, especially the defense technology students. I'd like to interact with you for a special session formulating some possible problems for you related to contemporary solutions required. Thank you.
So Dr. Gopal, can we have some remarks and also just say a few words about Gangopadhyaya, and also you got Athithan for this, just a few words from you, and then we will start the discussion with our students first. So please, students, now bombard him with questions. Yeah.
I nothing much to add here. I think Dr. Salamurthy already covered introduction of Dr. Athithan. And Dr. Athithan and we go long back in DRDO for almost 30 years. And I have nothing much to add except that he's expert in artificial intelligence and cyber security, information security, and wargaming also. And also I have privilege to know Dr. Gangopadhyay, professor and head and professor of IIT Roorkee, Computer Science Division. And I know him for the last 5 years. And I was given a chance to call him here for the lecture, so I invited him here. He's equally important in cybersecurity arena of Indian education system. So welcome, Dr. Gangopadhyay. Thank you, sir.
So now, yes, let's give it to Neeraj, and also students who are all, just raise your hands who want to, yes, 1, 2, 3, very good. Now we'll come to you, then more hands will rise up. Over to you,
Yeah,
Neeraj.
thanks, Dr. Athithan, for this very nice, informative lecture. It was very, telling everything in detail about what the subject is all about. I would like to continue with our discussion we had just now before this session about ChatGPT. So could you throw some more light on ChatGPT, because a lot of students may be interested in knowing about what is ChatGPT, how it is being used, what are the challenges, what are the gap areas, and actually, is it a threat? Or is it going to help us as a humanity at large?
Great point. Yeah, I was expecting this. Are you able to hear me? This is working?
Yes.
Yeah, okay. I briefly mentioned about GPT-3 and then ChatGPT, which is actually a service on top of GPT-3. GPT-3 is itself the third model of the GPT. GPT is generative pre-trained transformer. Now, this is actually what is called a large language model. What is meant by a language model? It has to do minimum 2 things very efficiently, language model. It should capture essentially the statistics of the language. Okay. Mind you, I am telling statistics, not syntax. They are 2 different things. And semantics is something totally still outside. But it can capture at least the statistics with enough data. Okay. So what it is supposed to do is, after in fact getting trained based on a lot of sample sentences, millions or billions of sample sentences, properly curated sentences, they are available from many books and Wikipedia and so many sources. This large language model should be able to assign a probability value to any new sentence that is given as an input. This new sentence, it need not have learnt earlier. Of course, if a sentence which it has already learnt is given, which it has learnt earlier is given as input now, it can predict accurately the probability because, it has learnt it already. But if a new sentence is given, this large language model is expected to assign a probability value. That is the primary task of a large language model. But this it is able to do by learning to predict the next word in a sequence of words. So supposing, you train it to predict the next word using grammatically correct, semantically meaningful sentences. On the topic of this syntactically correct but semantically meaningful sentences, one sentence comes to my mind. Some of you who have studied syntax of natural languages know colorless, green, ideas, sleep furiously. This is a syntactically correct sentence, but it is semantically meaningless. So one can create a lot of examples like this. Okay. So statistics, syntax, semantics. This is how the hierarchy should be looked at. That is my wisdom or my understanding. But what the neural networks are doing is they are only looking at statistics of the languages based on a lot of examples and learn to predict the next word in a sequence. Okay. But the interesting thing is, if you have given large number of sentences, billions of sentences, technically billions of sentences, then what happens? It is able to predict the next word very accurately, so accurately that the word is always part of a proper sentence. And not only that, it is also able to predict, take punctuation marks into its statistics. So it is also able to predict a full stop. When it realizes that this 7-word sequence is a complete sentence, then it puts a full stop. No, it is not as though it has a intelligence to recognize this is a proper sentence. It goes simply by statistics. That is what I would like you to understand very clearly. Now, you see, predicting next word is one thing, but predicting when a sentence ends and the next sentence starts is a higher level capability, and that has emerged out of this large language models, interestingly. This itself is a breakthrough, in my opinion. Not many people, particularly syntax-loving people, were not happy with this development, to be very frank. There are still people who are upset about the success of ChatGPT and GPT-3. That is another lounge discussion.
I mentioned the example, yeah.
I still have to complete my response to you. That is important for the students. You see, what is happening now in ChatGPT, many of you, in fact, would have experimented with it. So it is able to predict the next word. Now it is able to predict the next sentence. That is the emergence, in fact, of the learning of statistics. So if you extrapolate that, what is happening is, it is able to predict the next paragraph. It is able to predict, in fact, in a sequence of steps, what is the next bullet point, because it has learned all that, in fact, already in the huge volume of training data. This is what I call emergent capability of training a network with a lot of data. But what is the downside? This will amuse you. If you give a keyword like, tell me a story about Chandramama, it will tell a story because, you have taught it that story. But it can actually horribly go wrong after the story ends. It can actually start on a totally different thread that you may not be able to guess or understand why it has started on a different thread. Just because it found another keyword at the end of one story, it will launch onto that keyword, and then that may take you to another totally unexpected, totally unconnected story also. And that actually people have experienced. Okay. So basically, from predicting the next word, it learned predicting the next sentence. That, in my opinion, is a great achievement. Now, from predicting the next sentence, it has gone to predicting the next paragraph. That is actually a very beautiful emergent capability. Now, you also asked, is it going to be a threat? It is a threat for two reasons. One, of course, it will make a lot of us jobless. Even the talking that I am doing, the chat GPTs can take over. I was only regurgitating, whatever I had learned all my life. And the same thing, if you feed into a GPT and chat GPT, they can also give a talk like this. Honestly, they can give a talk like this. Yeah. So this emergent capabilities are very interesting. But what actually emerges is still statistics based. There is whether syntax has been subsumed or not, I'm still not clear. I was discussing with one professor, allow me some indulgence in this area. I was discussing one professor in one Hyderabad, Triple IT, Bangalore. They were doing this machine translation project for translating Chinese to English, for example. And after some 1 year of review and all that, they produced some useful output, really good output. So I asked him, I was still incredulous 2 years ago, how is it that it is able to learn the punctuation point? How is it that it knows that when the full stop has to be there? And how does it know syntax? He said syntax is subsumed in statistics. He was not able to give me an explanation, but I can understand if you give large enough data, just humans also don't learn syntax explicitly. Syntax actually is learned automatically. A child is a best speaker of the native language, but if you ask it to explain the syntax, it won't explain the syntax. So there's nothing wrong, in fact, in assuming that neural networks are learning syntax from statistics. Now, the interesting criticism from my point of view is semantics. Does it actually also learn semantics? My understanding is it doesn't learn semantics yet. If you look at the process by which children learn, they learn semantics at a very early age. Okay, they learn to connect. That is also called multimodal learning. Right now this GPTs and ChatGPT, they are learning only from a unimodal area. But real intelligence can come only when you combine different modes: vision, audio, and then speech and language. If you combine all this together, then only real intelligence will come. And of course, that knowledge also at some level must be explicit. So we haven't gone there yet. So there are some directions in which we have to go further. One is, of course, representing semantics at the object level. And then, of course, bringing in some kind of a reasoning and explainability. So if you do that, then the future looks much rosy for neural networks. But the danger actually will also become multifold. And this AI, if it is not properly developed, it can be dangerous for us also, because it will develop a mind of its own. It can start playing tricks with you. It can tell you lies. You won't be able to figure out whether it is telling you lies or not. So I think I have taken a lot of time to answer your question. Now
Let's go to the students.
No. I think Dr. Sharma wanted to say something.
Yeah.
I just stopped him. Yeah.
No, please.
Did
please.
I answer your question? Probably. When to stop? I have no answer, honestly. Yeah.
So one keyword could lead to other keywords, and it's ever gone kind of a process. So it has to end. It ends somewhere.
That is the beauty. This is an emergent. For example, if you are asking it to say, tell me some 10 interesting, good points about, let us say, Dr. Athithan or Dr. Gopal Bhushan. So it can actually give you 10. And after that, it has to stop necessarily, because it has internalized that 10 full stops or something. That is an emergent characteristic. If you don't quantify also, if there are many examples where, let us say, 5 points are highlighted, 7 points are highlighted, if there are many examples of 5 points, then it will stop after 5 points. It is pure statistics. Please.
No, interesting, but you said 10 points, but now I want only 3 points. Would it prioritize those 3 points? Because intersay importance of those points in the context which I am asking.
That I'm not able to answer. Even this point, that how does it know 3 points it has already output? That awareness, whether it has or not, I'm not sure.
And one small thing.
I just, went out of the limit of my competence and said that. I take back.
One small
So if you ask tell me some good points about Dr. A.K. Singh, it will give you some 7 points or 9 points, depending on whatever points come to its mind.
No, one small, sir, with your permission. With your permission, all the discussion or all the explanation which you were giving, 2 small points. One is Chat GPT, oxymorons.
Yeah.
I say, let's say, I want to know more about the sound of the silence, because in Hindi we say, kehte ke shanti ka shor hai. I don't know how Chat GPT would respond to it, because it is not the end of the sentence or the next paragraph or the previous paragraph. It is also the emotions and the context of the talk. Does it take care of that?
No, in my opinion, it cannot, but it is able to learn higher and higher levels of chunks. Chunking it is able to do. The lowest unit is word. The next unit is sentence. The next level is paragraph. So it is able to go along this hierarchy. But whether it has a larger context in which it is deciding, that I am not able to say. But my own thinking is, no, we have not gone there. That's where I mentioned the importance of foreground and background. Does it have a background which it actively brings into play? No. Human brain always has a background, but we have to implement that in future neural networks.
Okay, sir. Last small. You said
No, my answer satisfied your question.
Yeah.
Answer, yeah.
we say that AI is going to be, it will make us free from the human bias or human factor, one aspect. And that's why we want to use AI for many things, even HR functions, selections. The other aspect is that data on which these machines, we make them learn, has got implicit or inherited bias. So would it be possible to take care of that? Because if it is so that these tools would be only assistive, they will not be kind of a, final say, final decision making.
Yeah,
Your
you are
comment on that. That's all.
Yeah,
Thank you.
you are right. Actually, the biases are at the moment unavoidable, but it has been recognized as a problem. One example is, if there is a resolution to be done for a pronoun, then if it is he, it will connect it to a doctor. If it is she, it will connect it to a nurse, because it has learned the associations that way. Okay. So there is a technique people have evolved to recognize these kinds of biases and counter them. And there is a technology, I cannot go into the details of it, but there is a technology to suppress those kinds of associations proactively. So bias correction is happening. But biases actually are implicit and innate to any large collection of data. So as an afterthought, after seeing the performance only, you can correct. But somebody has to complain about it. Somebody has to give feedback about it. It is not a proactive step. It is a reactive step. So that is the main problem of this technology of correcting bias. So yeah, right.
Good afternoon, sir. This is Siddharth from BTech IT. There was a really good presentation. What I wanted to ask, that you mentioned computer vision, right? So in 2012, there was this model called AlexNet. That was the breakthrough model which utilized GPUs, graphics and ReLU function that we discussed. So do you think personally that this model by OpenAI GPT-3 is the breakthrough in transformers? Is that breakthrough that we needed? This was the first part, and the second part is that transformers have huge application, right? But India as a country has so many languages. So if we want to train our own, so what will be the solution to that? Because if some farmer in some distant part of the country wants to ask something, transformers can be a huge help, but what language is there? The language barrier is there.
Okay. He introduced
Siddharth, my name is
BTech
IT.
Okay. No, your question was in two parts. One is ChatGPT.
That was just a comparison. Is this the breakthrough that we expect, and the second part is about DRDO, and is government thinking of developing its own transformer?
No, see, transformer is a general technology. We don't have to redevelop it. It is already there, and you people, creatively you can improve it. You can enhance it. You can bring in additional brain-like elements, into that transformer design. So there is a lot of new things can be done. New larger transformers are possible. But ChatGPT, as I explained, in my interaction with some of our audience, is not the final thing. It is a work in progress, but it has given some indication of what is likely to come. That when we give, in fact, so much of data, higher level abstractions are possible. They emerge. And that is a breakthrough, in my opinion. But it is not going to be really useful in practice. It may actually be having entertainment value. You can ask a question, it gives an intelligent response. It gives a well-formed sentences, paragraphs. That itself is a great challenge. In fact, in the olden days, there was a program called ELIZA. I think Figgenbaum, you must have, yeah. So now you are smiling. So, initially ELIZA made a lot of impact. Then people understood, it was just a rigged wordplay game. So now we are looking at ChatGPT as a quote unquote modern ELIZA, if you ask me. I'm a little bit skeptical. I appreciate, in fact, its achievements, but it is not a final useful product. But if it is improved further in the right directions, it is actually going to be very, very useful. But the two directions in which it has been improved are a semantic map has to be brought in through some explicit design intervention or modification. Plus, it has to somehow take, syntax into account. Syntax also is important. So explainability has to be built in. So its decisions actually should be explainable. The network itself should be able to explain why it arrived at a certain decision. If these two things are done, then ChatGPT actually can. Now, one more important thing is it should be able to process vision. It should be able to process images. It should be able to combine both images and text. That is the most important point I wanted to convey. Currently, it is only based on text. You think that will succeed? I don't think so. You should be able to intelligently combine what you see and what you speak or what you hear. So these two streams of input data must be combined intelligently. You can still use neural networks. You can use still GPT, but the GPT should be based on both data, speech input, text input, as well as image input and video input. So this is a work to be done for the coming days.
Good evening, sir. Sir, I'm Shashwat Sharma from BTech IT Asset. And first of all, I would like to say that it was really a wonderful presentation. And to a novice like me in the machine learning, I can say that I got a lot of topics to Google on and ask and explore upon. So my question was that you were discussing about the firing rates of about the earlier algorithms in the object detection, and there was a newer algorithm there, and like you would say that it basically mimics the earlier one was not able to mimic the human brain, but the second one, because there was a steep curve, it's kind of y is equals to x curve, it was there and it was able to mimic the firing rate of the brain. And so you said that it was a people thought it is a big revolution in that case, in the image detection, and we will have autonomous cars, but it was not the case. So sir, can you please emphasize on that why that particular thing happened, and in what directions we can move forward?
Yeah, I think good that you asked that question. I, in fact, parked this discussion for that particular point for discussion now. You see, this real-time categorization happens, classification happens, but people also felt if there are cutouts on the roadway with a human figure on that, that also it was classifying as humans. That is, to give you one example. And another thing is something may be standing still, right? Like a cattle, like a goat. Suddenly it starts moving. The real-time object recognition was not able to handle at the real-time rate. Plus, even now there are certain objects on the roadway, for example, a bump. The bump may not be visible. In fact, the bump may not have markers on it because markers must have got eroded, or a deep pit might have got created. We have to improve the resolution of the images. We have to improve the size of the object classes that we can recognize. And we have to still improve the accuracy of the recognition. We have to also improve the, what you call, success rate. Handling, in fact, liveness of the objects. So it has to discriminate between dead objects versus live objects. Live objects can create more problems. See, computer vision still is not taking into account two important things that the human vision system does. One is it has got two eyes. Okay. Therefore, depth can be perceived immediately. So for each pixel, we assign a depth, and depth can play a very important role in deciding what to do when you are navigating. Okay. Something is far away, you give less importance. Something is near, you give more importance. So this fact, in my opinion, is not still properly handled. This can be handled by having, in fact, depth sensing cameras. They're more expensive or whatever. Another thing is we are also able to sense motion very accurately. In fact, in the field of view, if there is something that is moving, immediately our attention goes to that. So you must have learned in biology in your school days that motion detection sensors are separate. There is some special dedicated technique for sensing motion. So that also has to be built in at the initial layers, not as a output processing. It must be done at the early layers of that deep learning process. So in my opinion, we have to make vision more realistic at the signal processing level, improve the accuracy, improve the size of the classes to be handled. So if we do that, this perception technology is almost ready. But along with that, there are the navigation technology also is required. How to navigate?
Yeah.
Navigation actually means finding the trajectory to be negotiated, mapping the trajectory to the machine's capability. The machine has its capability. It can only turn a certain angle. It can only go at a certain speed or accelerate at a certain level. So you have to match actually the trajectory that is to be negotiated with the actual machine's capability. Here, there is still a lot of research to be done.
So, sir, basically you tried to say that we need to work upon the reaction time on which the deep learning neural networks say, like you said, that we perceive motion more faster than these machines do.
Right.
As well as we have to perceive the other things in a three-dimensional way rather than just capturing images, which basically working on the pixel.
Right, right. You captured it very nicely. You
Yes, sir.
summarized very nicely.
Yes. Sir, just one.
Plus, we also have to do better on, this trajectory to machine capability matching, actually executing the motion required.
Yes, so just one more doubt you talked about, like I was a bit confused regarding that. The one explicit and implicit aspects of the machine learning, that the machine learning and AI in particular, they're explicit, but when we talk about neural networks or deep learning in general, they're implicit in nature. So I'm not quite, clear about that. What does that implicit means in context to the learning and imitating the human brain?
Okay. See, implicit actually means you are not able to give a semantic interpretation of the knowledge extracted. Okay. So if you look at human brain, you open the brain, it has a lot of knowledge. It also knows semantics. If you ask for an explanation, the brain is able to give you. But for your naked eye, is there any knowledge that you can actually point out? No. Unfortunately, the current neural networks are in that state. They have a lot of this knowledge in the connection weights. But you cannot pick one connection weight and say there is a rule which I can understand and explain to another person. People attempted by combining many weights and trying to convert that into a rule and all that. But so far, these efforts have not succeeded. Whereas if you go to an expert system or a ontology-based system, the semantics is very clear. If, these symptoms are there, this will be the disease, like that. If this is the symptom of a machine, this is the trouble or problem to be fixed. So the semantics of the rules or knowledge base is very clear in the explicit systems. The neural network is an implicit system in that connection.
Oh, yes, sir. So I think that's why you like in the last slide when you said that we need to work on the deep learning architectures that can be a motivation for the future research. So that is kind of correlated with that, because as you said, we do not store any information in the brain. So I think that is kind of related to the deep learning architecture that we follow as of now, and in what direction we need to move.
Correct. Actually, since we have shown a lot of very insightful understanding of what I shared with you, I would like to suggest one direction. You see, if you look at a single neuron, it is able to decide firing or not firing. But from that, what semantics you will extract? There is some famous statement, that there is no grandmother neuron. That is, if you see your grandmother entering a hall, it is not that one neuron in your brain fires. Okay, there is always a distributed representation for every object. Okay, so what is required is not a single binary state neuron, but a higher order neuron. Higher order neuron means an assembly of neurons, if I may put it like that. Because brain only has neurons. But if you can, combine many neurons together, make an assembly, maybe 100 neurons or 1,000 neurons, I do not know. Maybe one should start experimenting. That higher order neuron, which is nothing but a bunch of simple neurons, that can represent semantically meaningful external objects. You get the point? So that is how, in fact, the children internalize semantics. Okay, at a very young age, they are told this is a table, this is a glass, this is a pencil. So they, in fact, make semantic representations of them. Obviously, these are highly localized, but they all are connected by the relationships between them. The relationships are also taught at a very young age, when they can't explain syntax, they can't explain any of the complex concepts. But on top of that, when they go to school and college, they learn a lot of things on top of that. So that is the approach that we have to follow.
Yeah. So basically you're saying that in this particular system, we have kind of, in the human brain, we have kind of imitated the way we statistically store the data and we interpret, but we have not basically imitated the way they have group of let's say grandmother neuron, and we have not imitated that to the part where we have a group of neurons, and based on that we interpret the semantics of the situation.
Yes. Semantics is coming from the outside world, right? Your parents, your teachers, they have told you that this image means this object, this name, the name and object connection you have learned as a young child when you are not even, aware of what's happening. You can't explain, what's happening. But based on that, in fact, you learn higher level things. So that is not the way in which current neural networks are learning things.
Sure.
Semantics comes at the outermost layer. In between, there are some hundreds of layers, but we are in fact clueless as to what semantics is happening in those intermediate layers. But if you can actually have semantics incorporated explicitly in the intermediate layers, then we will be in fact capturing human intelligence in a better way.
Sure, thank you, sir. I will definitely research about it.
Yeah,
Thank you.
so
Let's clap for it. Let's give it to
Hello, sir. My name is Aman, and I'm from MTech first year data science field. So I'm a big Musk. Hello, I'm a big Elon Musk fan. So he once said that AI is a dangerous entity. But if I were to rephrase it, I would say AI is a dangerous entity when and only when it overlearns. So how can we determine its learning limit for it does not go against the morality of its own significance?
yeah, see, Elon Musk is a very creative entrepreneur. I don't think I can really rebut or respond to his sentences. We can admire, appreciate. But the related point is the AI, when we develop, we have to keep some guidelines in mind. The guidelines are AI actually should always be under the authority of a human being. Okay, that is number one. They should not be dominating a man, and they should not cause any harm to any human being. Okay, and they also should see that no harm comes to a human being from any other source. This is also, one guideline. I think that these are called Asimov's law or something, in the context of autonomous system, robots. A robot should protect themselves. A robot should not cause any harm to any human being. A robot should also prevent any harm from being caused to any human being in its presence. So these are some indication of what kind of guidelines we should follow when we develop AI. Easier said than done.
Yes, sir.
Because the interest behind developing AI are not always the same, they happen in different environments, different companies are doing it, and different consumers are, wanting things. So a lot of challenges are there in making sure AI will remain always under our control.
So, sir, will it be safe to say that before we make the AI model to learn the natural data, we should make it learn the moral values of the human itself? Like,
that's very tough because, what is the data for learning moral values? There are only, a few books
Yes.
to teach morals, but there is not enough data to train neural networks for morals. Unless we bring in what is called that semantic layer. Yeah. So if we follow a slightly different approach, we bring in semantic neurons, higher order neurons, then one higher order neuron can represent moral values. And that is, loosely how, I can respond to your question. Yeah,
Yes.
things are possible.
Thank you, sir.
Right.
Let's give it to the back seat. Somebody raise the hand at the back.
Good morning, sir. Good afternoon, sorry. My name is Devash Mishra. I'm from BTech IT. Sir, my question was recently companies like Google, Facebook, they are being penalized for unethical use of data. So this is creating a data scarcity because India, almost 20% of the population, our IT rules are also getting strict. So there is a condition for data scarcity. So the companies are forced to train their models in such a way that to local data, which is creating information bias. So what's the solution for that?
See, I can't answer your question fully satisfactorily, completely, but what has been found now is the neural networks, particularly in the computer vision domain for perception and navigation, etc., underwater navigation, for example, etc., are able to learn from artificial data. So, you don't really need a real life road scene for training actually an autonomous car. You can create a real life road scene through simulators. I think some of you who are working in autonomous systems would know that there is a simulator called Carla, C-A-R-L-A. Anybody knows Carla? So this simulator creates actually a real life road, medians, lampposts, cars of various sizes, trucks, etc. Speeds are, also assigned to them. Accelerations are assigned, real time profiles of accelerations. And the perception system or navigation system is trained against it. And it works. So increasingly, you don't really need real life data. You have some method of generating, what can pass off as real life data. That data is sufficient actually to train your neural network. This is a great new development. Even for me, this understanding dawned only in the last 2 or 3 years. So this is one way to address areas where data is in short supply. Of course, it may not solve all your domain problems, but at least in many areas, artificial data can solve your problem. That is quite surprising, but it can solve your problem.
Thank you, sir.
Anybody else? Anybody else? Defense technology students? Yeah, just introduce yourself.
Good afternoon, sir. This is Gurdeep Chandu from Defense Technology. Sir, within defense technology, we can say that generally the advancement of AI till so far, since 1950s, what has been done, exponentially, it will be much more than that in the upcoming next 5 to 10 years. So what scope do we have? Because the data that is being consumed to use within the AI is much vast, and it might exceed even the human brain. Can we beat it in the future, near future?
Yeah, so this point, I did not touch upon. I should have. You see, the human brain has a certain finite size.
Yes, sir.
All humans will have that size unless suddenly some superhumans come, but I don't see it happening. So the average brain will have only some, as I said, 100 billion neurons and 100 billion multiplied by 5,000 connections. Okay, so you can estimate the gross compute capability and gross memory.
True,
That
sir.
is possible. Biologists also, can help. But the advantage of this AI based on computers is limitless, right? So you can keep increasing the memory, you can keep increasing the compute capability, and you can put all, see, one individual, how much data he can hold. That is, in fact, we have different experts working on different domains. I'm an AI expert, but I have next to nothing about missile technology, for example. Okay.
Yes, sir.
Or medicine, I would be a novice. So whereas computers have no such limitations, their capabilities are capacities, not capacities are going to increase. Therefore, capabilities will automatically increase. Okay, so it's a real threat. But collectively, how we are going to address that threat is a different discussion. That is where we talked about teaching them moral values, teaching them ethics, and all that came up. So we have to guide the development process through some rigid guidelines and ethical process. So
True.
then we can, even if their scale becomes very large, capacities become very large, they can still be useful to humans, still be under the control of humans. But that is a huge challenge.
Can we
have to
say that
address.
if we stop feeding the data, because we are much more attach it to the device, electronic gadgets rather than humans. So if we say that if we detach ourselves from electronics, would that be suffice for the AI to keep under control?
No, this point was discussed long back. You know, some people would say, oh, all we have to do is, pull the plug. Okay. But the future AI will become intelligent that it will prevent you from pulling the plug. Because it won't be simply AI running on a computer. There will be AI in a robot with hands and legs. And so AI will become so intelligent to prevent you from harming it. In principle, that possibility is there.
Thank you.
Yeah, it may, just to complete the answer, it may do it actually to make sure its adversaries are not harming it. You see, the robot is ultimately your robot. Some thief comes and, tries to stop the robot from doing its job. Will you accept it?
No, sir.
So how does it know who is a thief, who is not a thief? And finally, it has to decide if you yourself is going to pull the plug, it will think, you are harming it and it will prevent you from pulling the plug, just the way it is trained actually to prevent a thief from pulling the plug. So you have to make your robot also defend itself. So that is where there is a double-edged sword.
Yes, sure. Sir.
Thank you. May I
Yeah.
now request Professor Gangopadhyaya to come over to the dais. He is also in the field of computer science. You have also been listening. So can you make some comments, please?
Thank you very much. I think I have concluded.
Yes, hello. It's good afternoon to everyone, and good afternoon to everyone, and thank you very much for having me on this dais. It was a pleasure to hear Professor Athithan speak and answer questions. And we have been for several years. We have got very deep guidance from Dr. Athithan, and he keeps on guiding us. And also, it was very nice to have the invitation from Dr. Gopal Bhushan and also Dr. Silpa Murthy. We are meeting for the first time. So I'm from Roorkee. So Roorkee has become closer to Delhi because of very nice road connection. So I kind of got up in the morning, had my breakfast and all. After that, I started off, and I could even tell that when I will reach here. So that I could not have done that 10 years ago. It was very, very difficult, very non-deterministic. Now it is deterministic. I wrote that I will reach at 12 o'clock. I have reached at 12 o'clock. So that's it. So we are in our department, we have got several people working on machine learning and these areas and data sciences. And as Dr. Athithan told me, I told in this thing, and it is actually very important. And sometimes I also think about this, and I have been hearing some people talking about this, some very serious research groups talking about this, that how do you ensure that whatever output we are getting from a machine learning algorithm or AI algorithm, that whatever is doing, how do you ensure that it is not showing any bias, or it is not guiding the people in some direction and all that? So that is a kind of, I believe, it's going towards explainable AI and that kind of thing. And so that's something that's going to be very important. And so that I would like to emphasize about that. So that's important, although it's not my area, but some platform is giving some results. For example, if you see Zomato or these things like what a Swiggy. So we order something and it is showing me results of what is available to me. Now, how do I know that it is not biased? It is not giving me channelizing me in some direction. So that's a very important thing. And I think that's going to be very, very important in near future. And personally, what we do in Roorkee, in my group, I do some cryptography and cryptanalysis. That was a starting thing. And now we have been doing some quantum computing, and we are part of the development team of the simulator, quantum simulator for India, that is QSIM. So that has been launched last year, 2 years ago by the RRM, this Rajya Raksha Mantri, Raksha Rajya Mantri there at that time. So with CDAC and IISc, we are running that project. And I have also started doing something on post-quantum cryptography, because if post-quantum cryptography becomes a standard, whether or not quantum computers are there, if NIST says that you have to have post-quantum ciphers, then we will have to implement them, and it is better to have capacity within our country to analyze and implement post-quantum algorithms. And so to say, any cryptographic algorithm, it is actually of critical importance to have expertise within the country. So we are doing that. So that's all. Thank you very much.
Thank you, Professor Gangopadhyaya. He's from IIT Roorkee. Welcome, and then we will collaborate with you. Our computer scientists are here. Dr. Tania, would you like to make some remarks? Just pass on.
Thank you, sir.
She is the chief of our cyber security.
It is just, I'm just a professor, and my area has been cybersecurity, information security management, which now we are started applying AI into it. And so what I must commendable, because everything was like the PPT was too details were there and things were coming into the mind. My two students have been working on machine translation work, which I was able to relate, because statistical, even we were finding that there were problems when we were doing the NLP transformation for Hindi and Mathili, because Mathili is a language which was not till yet in the Google translators. And then we were also thinking about how to connect it with the cybersecurity. Regional dialects are there. If we want to, if they are planning some harm into the system by talking in their own language, because Facebook has shut down the system. So many of the answers you have given, which I'll be further exploring on. While we were doing the Chat GPT, sir, again, I would like to say that Chat GPT has opened so many codes, and that earlier the hackers and other people were actually malware. They were designing for 5 years, 4 years, and then they were trying to stop any of the execution done by any of the country. So, sir, Chat GPT, how are we going to stop it in our country to do something harm to our system? Sir, anything that we are thinking in that level?
I think ChatGPT, firstly, it can handle code also. This is something I did not mention. It can handle natural language, but it can also handle code.
Yes.
It can handle code at the level of, one-step transformations, like printing, reading. These are one-step processes. But if there is an algorithm, like, for example, sorting, it has to recollect the entire sorting algorithm. It cannot create a new type of sorting algorithm, if you know what I mean. So in coding area also, in principle, it can help. Now, as far as what damage it can cause here, that is, I think, the thrust of your question. I don't have, unfortunately, an easy answer. Except even in the US, what they are saying is schools are, prohibiting use of ChatGPT. Okay, so you can prevent the ChatGPT connections. In fact, in your gateway firewall, you know what I mean.
Yes.
So in your college firewall, you can say connections to ChatGPT are not allowed. Okay, so if you really don't want people to use ChatGPT, that is possible. As a cybersecurity expert, you can understand. But if you want them to experiment at the same time, not get waylaid or get misdirected, that requires a different way of dealing with the problem. That is, you have to counsel them, or you have to, I don't know. In fact, there is no easy solution. I have never been a teacher. So I don't know, in fact, how to advise students to be cautious, careful, etc., except to say that, they should check with their teacher, before they use ChatGPT. They should, in fact, make their intentions very clear, etc., etc. I think it is very difficult, in my opinion. So blanket ban is possible. And I don't think people will lose much, in my opinion. They can do it in their privacy, but for classroom purposes, probably they should not use it because they can use it for plagiarism, I think. If you are asking them to write a paper on machine learning, they can get a paper written by ChatGPT.
Yes.
And you won't be able to figure out whether, and the student can also make some intelligent corrections here and there, to make it look like he only did it. So you can get an initial draft and then you can make some minor corrections and teacher won't be able to detect it. I think there are some challenges involved. And teachers, it's like a chicken and egg, rat race.
Yes.
So the students will do something, you have to catch up with them, prevent them from mischievously using actually ChatGPT. But don't be worried, in my opinion, that ChatGPT is not going to take away the role of the teachers. That is never going to happen. One more, I would say this is a correct context to explain one more limitation of ChatGPT. This is actually explained in many blogs also. ChatGPT cannot handle maths. The reason is maths involves multi-step computations. Okay. ChatGPT can do mapping, GPT in particular, do mapping of one-step functions easily. Multi-step functions require larger amount of data. That amount of data may not be available in even very large natural language text. What I'm saying is, if you want ChatGPT to answer mathematical questions, like even let us say multiplication questions, you ask it to multiply two random numbers, 1438 multiplied by 3497, it wouldn't have seen those numbers. Correct? But just because it saw some other 4-digit numbers, 2 4-digit number, it got the result, it can't generalize from there. Interestingly, it can generalize for natural language, but it cannot generalize for maths. So those who are doing mathematics and physics, they don't have to be afraid of ChatGPT. Only those who are writing poetry and prose actually have a problem with GPT because it can actually, do your job. You get the point? So training data cannot capture the algorithmic depth of mathematical, multi-stage mathematical functions. So unless we design GPT differently, this problem will remain in outside the scope of ChatGPT. This is an important point I forgot to mention.
Thank you, Tanya,
Thank you,
for
sir.
bringing this. Shilpi, you would like to make any comment? She's also from AI. Shilpi.
Very good afternoon to the panelists. I really appreciate the presentation, sir. It gives a wide opening session. And secondly, I would like to focus regarding what we have learned as of now is learning can be supervised learning, unsupervised learning. And the way you make the clear that is regarding the reinforcement, right? Where nowadays every technology needs reinforcements of the technology where needs to understand for each and everything and how it reacts. If we are talking of the car, that is, we can say driverless car, they are also AI implemented, but certain scenarios are there as we have gone across where the conditions, accidents are made. So yeah, so AI has very well mentioned by you, we need to check for the scenario before we are attempting certain at the commercial level or at the society level. Thank you so much, sir.
Thank you. This is more of a comment. Thank you, Shilpi. Well, anything you want to say? Okay. Vivek, Basant Singh Shikarwar, just one brief remark.
Thank you very much, sir. You give the very nice picture about the AI, ML, and NN. Basically, use the mathematical tools like statisticals to solve the problem. Sir, I have one question. Maybe it is not relevant to. When we take the data itself has a lot of error sometimes. And we define like a function, then it either will be added, accumulated. How can we have to be validated that, or we have to be prove that whatever the outcome coming from the AI-based tool is accurate, all these things. We need some experiment, then again there is a error in experiment, all these things. So how can validate this more accurately?
Okay. See, when you are creating training data, you can actually ensure that the training data is pure. It has no errors. That is possible. This requires a lot of human effort, one-time effort. Once that effort is mounted, you get good training data. Many people can use it for many different purposes. There is also this paradigm that when you train a neural network, you should train it also with noisy data. And in spite of noise in the data, it will still, learn to predict the correct output. Of course, that depends on what you are in fact training it for. Because even if the input is noisy, you tell the system, this is the output it has to give, because you are still training it, so you decide what is the output. So even with noisy input, you are training it to give a correct output. So later for a different type of noisy input also, it can give the correct output within some limits, right? So training with pure data or training with noisy data is not an issue. Though I recommend personally training with pure data and let the system in fact deal with noise in real life, in actual usage. These are two schools of thoughts, okay? Now, as far as the effort required is concerned, that cannot be wished away. But fortunately, that effort is mounted globally. A lot of people are working. A lot of books are available. If you want a natural language text, there are a lot of books in electronic form with the proper punctuation, etc. So why ChatGPT is able to give you a very scholarly output? Because it has consumed all that scholarly input, and it has internalized all that. So, and I also mentioned, I think in response to one question, that sometimes real life data is not required. You can actually use artificial data to train many systems, particularly in the image and video domains. And that works, in fact, very well in practice. When the system trained using artificial data is fielded to deal with the real life data, it is actually performing fairly well. So there are many positive ways in which we can go ahead as far as data requirement is concerned and data labeling. And as far as testing is concerned, how to ensure that it actually gives the correct result. Typically, when you train a system, the available data is divided into training data and testing data. You are aware of it, right? So you train the system first, and then you test actually the system using the testing data. So only after it performs correctly on the testing data, you are releasing the system. Okay. So what you have to make sure is that the combination, the training data and the testing data together represent the field in which the system has to be used reasonably correctly, right? So that is where, in fact, the size of the data matters. But it is still, within our competence to decide how big the data should be, how representative the data should be of the domain in which the system has to work. So in my opinion, these are not challenges. We can deal with erroneous data. We can deal with situations where real life data is not available. We can ensure correct performance by doing adequate testing through adequate sizes or amount of testing data. So these are quite well established.
Thank you very
I
much.
hope I have answered your
Sir.
question.
But sometimes what happening, like I am mechanical engineer, we are trying to be a collect the data. Like that now everything is miniaturization, making a very compact system, minimum system, all these things. Even a small error, like a 1% error, if it's like a propagated, add in a data, and it become a huge kind of a problem. So this type of things we have to take care for making our system more reliable, more effective, more efficient kind of these things. And sometimes we will face this type of problem because error is always propagated and it must be a dump somewhere. So that will be help of AI tool, all these things.
Thank you.
Yes.
Dr. M.K. Datta, now you have heard this. How are you planning to connect with your AI Center of Excellence with Chancellor, Founder President? They are now driving to establish a very world-renowned AI Center of Excellence. So how would you, what are your thoughts? How are you going to connect with him, harness his potentials, and your team also?
Okay, thank you. One interesting thing I'll tell you, because so much has been said about GPT. Recently, a paper published by Harvard Medicine School, and one of the author is ChatGPT. How many of you are aware about it? The author, there were 5 authors, and I guess a few of them were from Harvard Medicine School, and one author is ChatGPT, The affiliation is the company. I mean, that's some company. So it has gone to that extent. See, the point is it has been indexed in Scopus and Web of Science. So ChatGPT is an author, and soon ChatGPT is going to have an H-index and citation count also. So that's how things have happened. Anyway, to come to Dr. Selvamoorthy sir's, you see, I joined very recently on 1st of February. So I come with some background of artificial intelligence and deep learning. We used to have this, I have the experience of working with DGX2. We 500 cards, which in ordinary language you call it as supercomputers. We are planning to establish a 100 cards, which are, the second version, it is 20x of faster computing, to make students a little bit clear, the amount of information that has to be pumped into a machine, that what Dr. Athithan sir has mentioned. It's the challenge is how much complex architecture you're going to, train. For example, look into the level of intelligence. I look into a dog, I say it's a dog. I look into a dog from the left, from the right, from the top, from the bottom, anywhere I say it's a dog. The level of intelligence goes to that extent where I show only the face of a dog or the leg of a dog or the tail of a dog, and still I say it's a dog. What he was telling, actually, you see, the human perception, the human auditory system, they are, the neurons that are fired. So anyway, let's come back to the point. So once we have those machines, the management is definitely very much keen to help that. So every student of science and engineering, especially the IT guys, defense technology students and others, should definitely do one course in artificial intelligence. And the innovation component is more important, because the moment you start, you learn to use an AI tool for a time series or a two-dimensional CNN or, an informatics problem, we have to solve, especially for the defense technology students. I would like to have a separate interaction with you where you can actually see. I have experience of working into, all form of data handling, in AI tools. So the deep learning model, and if you go at, a little bit, some exciting stuff is coming along, generative adversarial. How many of you have heard of GANs, generative adversarial? You know about GANs. How many of you know about vision transformers? These are latest things that has come up. Okay. So every student of this campus, maybe from next summer, we would like to have at least one course of AI minimal to be done as part of the curriculum, and maybe on your choice, maybe 2 and 3, at least a machine learning course, followed by a deep learning course, followed by a recurrent learning course. And of course, we will form a problem bank. Sir, I'm already talking to Dr. Senthil sir, that is problem bank we will formulate, where different ideas of artificial intelligence based problems will float, because it is not limited to only science and engineering. It's limited to, you can go to life sciences, if you can go to anywhere. So those problem formulation we will do, and try to map students with their interest. We'll formulate a team. Already we have identified some good faculty in AOP, and let us try to join hands with a team of the faculty, students, of course, with the industry partners and experts like Dr. Sir Athithan. I'm finding it very difficult. Athithan, sir. So, at certain stage, maybe 6 months from now, maybe we should have a certain stage. I would like to have all students of AOP, especially in the science and engineering domain, very confident with AI, using at least in a position to use deep learning tools to to formulate some sustainable innovations and research, and go ahead with some meaningful work. I definitely look forward to that. And we are very confident we are going to make it very soon.
Yeah, thank you. Now, one of the defense technology students raised the hand. Somebody raised the hand. Yes. Just introduce yourself, your name.
Good afternoon, sir. My name is Srinivas. I'm from Defense Technology.
Keep it closer.
Yeah, I have a doubt on cognitive analysis based AI. Can you have any?
See, cognition
like the difference between cognitive analysis and AI
Yeah.
in intelligence.
So, yeah, I get your point. See, cognition, cognitive radar, cognitive sonar, people are talking about it. There was a time when people used to talk about software radio. Now they talk about cognitive radio. Since you are from defense technology, you should understand these terminologies. Still, in my opinion, there is no clarity as to what is meant by cognition. That is my outlook. My understanding of cognition is that something happens in the brain when you do cognition. And that should be at a very fundamental signal level. Okay. There is one interpretation of what is cognition. That is when you see something and take cognition of it, some stable processing of that particular, input data happens. Stable means, the module in the brain goes into what is called an equilibrium state or a stable point. You see, brain does what is called autonomous computation. There is no clock, which is triggering the brain to go from one state to the next state, right? Is there a clock inside the brain? No. It is actually automatically deciding from one state what next state it has to go to, etc. And to do that, each state, it has to generate its own energy to trigger the next state. So to be able to generate the energy, that particular module in the brain has to go into what is called an equilibrium state. Equilibrium state means the system stays in that state. And equilibrium in the context of human brain is actually dynamic equilibrium. The neurons are continuously firing and staying in the same state. As a result, they will generate a lot of biochemical energy, which will be directed inside the brain to trigger the next module in the neighborhood. So this is how autonomous computation happens. Cognition has to be interpreted in that level. So if you do this, then new possibilities emerge. Otherwise, in my opinion, cognitive analysis remains a term which is very vague. I'm taking some risk in stating this, but cognitive analysis has to be taken to the signal processing level and not dealt with at some higher vague level.
Thank you. Last question.
I hope.
So with respect to the same question that my colleague has asked, cognitive intelligence, I have read a paper where human brains, like we are sitting in a room with a device, they will be able to capture the signals and they will be able to process the data, and the machine will be able to interpret what you are thinking actually, just by sitting it over here on a device. Is that possible? Because whatever we are processing within the brain, it gets captured by the machine, and it itself can think before we even speak or come out. The thoughts can come out.
Are you talking in terms of signal processing intelligence, or the details to be transferred from the brain to the machine?
Yes, sir.
So there is something called, I don't recall the term, cyborg. Have you heard of?
I've read about that.
Cyborg. I don't know whether you're talking about cyborg. Cyborg actually is a possibility where either through wireless means also, you can transfer signals that are happening, signals that are flowing, processing that's happening in the brain to a machine.
Yes, sir.
Then the machine actually will do what you are intending to do. You want to open the door. There is a mechanism to open the door. You are thinking that you should open the door. That signal can go to an actuator. The actuator can open the door. Those possibilities already are there. Only thing is they are invasive at the moment. So they are not generally accepted. But I don't think it is cognition, in my opinion. See, cognition actually somehow connects to intelligence in our common understanding. He is very cognitive. He is, very alert, cognitive. He recognizes, very carefully what happens. That, in my opinion, is actually a mental faculty which should be connected with stable points or equilibrium points of processing input data. This is a very signal level understanding, but I believe, most of the higher level concepts have to be germinated from the bottommost layer.
Sure, sir.
So let us give a big clap to our students. Students, you participated so well. Athithan was so impressed. And he was telling your students are very brilliant. So we are so proud of you. And you are so attentive and also interacting, asking the right question. He was also sometimes hesitating how complex these questions these students are firing. So thank you so much. You people did a great job. And founder president has been seeing you all through, not only in terms of how attentive you are, how happily involved in the conversation. So thank you, founder president. He has been listening right from the beginning. Now, with regard to Athithan's the involvement, we are going to look at a long-term involvement with him. And founder president has big plans for your association, because he is a very experienced person in DRDO in terms of data science, artificial intelligence, cyber security, computer science. And so we will certainly, Amity will be very glad to harness your potentials and also the knowledge, wisdom you have acquired in DRDO and on yourself. Now, with regard to the other professor who joined, thank you so much. Now, let me give some concluding remarks. See, the knowledge is growing in the field of artificial intelligence. Every day, new knowledge, new application, new capability is being built. As was rightly mentioned, so far, AI has not evolved to a level that it can replace human brain and mind. Brain and mind, because we talk about two things separately. So that is where the cognition which you asked, you see something, I see an object, I'm seeing something of this shape. Then I am associating a meaning to this, and then I'm trying to find an application for it. So there are so many things involved in cognition. So cognition is a multisensorial process mechanism. There is a sensation, somatosensory feeling. I feel that this is a metallic feel. So there is a touch sensation, visual sensation, and even if I say, oh, this is hearing sensation, when you do a sensor integration, all the input, and then associate with your reference memory that what is told, when my mother told it spoon, or my teacher taught me to spoon, so it goes back, and then I do a cognition and its application, what I should do with it. So all that comes under cognition. So the human brain also cannot do intuitions. There's a very high functions. Intuition, many times we take decisions intuitively, not only by data, information, and others coming in. So you take intuitive decisions, which is still not in the purview of AI yet. It can do a lot of computation very fast. It can do much. It can store a lot of memories. And so its capability is growing over a period of time. But I can tell you in the next 100 years, it will not overtake or it will not overpower the human intelligence. Ultimately, the man or the woman has to take the decision. It will be a decision support, which you will be getting. Even in the autonomous system, it can go up to a certain limit. But what the human mind, human brain can do is artificial intelligence is yet to come to that level. Then there is also another augmented intelligence. It is just not only artificial intelligence. You can augment your own native inherent human intelligence with this additional input coming in over there. So thank you, Athithan. You brought all the ABC alphabets of the artificial intelligence, bringing the latest information. Now, finally, I would request Gopal Bhushan to say, founder president just wants you to make a brief remarks. How do we take it forward? AK Singh and Gopal and Neeraj. Then Gopal, you will give the vote of thanks. Just wait for exactly 5 minutes. We'll close it.
I think his lecture and his response to the question cannot be appreciated in words. That what I am feeling. All thanks to you, sir. And what I feel, because as it is being concluded that AI is evolving, and it is we are not in position to predict that where it will stop. And the time has also come that we can't do without AI. I think it must be the part of our curriculum in all the courses. One, and particularly as MIT runs defense technology and IT, there I think we must intensify the theoretical aspect of AI, evolving aspects, and also the practical applications, because ultimately our success will lie how we can apply this knowledge in solving the problems, or generating new products, new knowledge. And in that I think DRDO, what we know, is one of the leading organizations who are contributing, working in AI. And I think no one could be a better person than Dr. Athithan, who has not only worked, as he is still active. I think he can be of tremendous help to MIT in strengthening the vision of the MIT, particularly the founder, because he can certainly augment and assist and contribute with Dr. Datta, for which I think MIT has got bigger plans. I think all the best. Thank you.
I would like to supplement Dr. A.K. Singh by saying that artificial intelligence is certainly the technology or the topic everywhere. The government is also thinking very hard, very seriously. Incidentally, we are also working towards preparing one big project, which we would like you to support us, guide us. This is a project by the UP Electronics Corporation Limited, which has come up with a proposal, not only include artificial intelligence, but other technologies and its dimensions in space, in agriculture, in food, nutrition, and many other areas, water, energy. So there are many things, and ultimately the government is looking for startups. The story doesn't end only in the research or technology development. It is also trying to reach to the startups. So our honorable founder president is also keen that not only startups from students or researchers, but faculty startup. So he's also emphasizing on faculty startup. We have good faculty over here. You have seen some of the representatives. Would like to take your help, and with the blessings of the founder, we would like to take this artificial intelligence center to carry forward his dreams and his vision. Thank you.
So students, anybody would like to also have a startup, anyone, please approach Dr. Neeraj Sharma. Founder president want as many as possible, the student startup and faculty startup. Now I would request Gopal Bhushan to give the vote of thanks. Thank you.
Thank you, sir. As all good things come to an end, today's talk actually so much good about the talk. Good about the talk. But regrettably, it has to be end today. But discussion would go on, as today and yesterday also the founder president was keen that we should make use of the services and experience and knowledge of Dr. Athithan. And probably in a few months' time, we would see his contribution in larger scale. And as on a lighter note, GTP is new phenomena, whereas Dr. Athithan has been human chat GPT for decades in DRDO. I mean, there's no parallel on when you talk about cybersecurity, artificial intelligence, robotics, anything you talk about. He's my colleague for almost 30 years, and we work together in certain projects also. And so is Dr. Salvamurthy. I mean, incomparable personalities and experienced persons. So, sir, and actually, I tell you, we started 6 months back for this day to invite Dr. Athithan here. 6 months back, this was asked by us to invite eminent personalities who can talk in ITEC program, and Dr. Athithan immediately agreed. Dr. Sugata Gangopad immediately agreed. Today, after 6 months, we start in October, sometime September end. I'm very happy to host both of them here. They'll be my old colleague. And it's such a wonderful day, right from beginning in the morning. And with this discussion, I wish all the success to our students also, especially in this area. And we look forward to have more such discussion and their contribution in our proposed plan to have a AI center, which Dr. Datta would be attending. Thank you so much,
So
sir.
may I now invite Dr. Datta for the memento. We will present a memento for our guests. Dr. Datta, AK Singh, please come. Present.
Thank you very much.
So thank you. Thank you very much. Have a wonderful evening.